Okay, so let's start with exercise number 9 from mechanics. Exercise number 9. Number 9. Exercise number 9. At a moment in time, T0 is equal to 0. T0 is equal to 0. A force that depends on time according to the law F is equal to eta T, where eta is a defined constant. So we know eta. Eta is a defined constant, begins to act on a small body of mass m. So this force begin to act on a small body of mass m. That is lying on a smooth horizontal surface. The angle between this force and the horizontal plane is alpha. Angle is alpha. And there is a picture. I'll try to show this. So here we have a horizontal plane and a body upon it. This body upon it, rigid, smooth plane on rigid body upon it, and here we have a force F. Force F that is directed in this way. And the angle between horizontal direction and force is equal to alpha. This angle is equal to alpha. So we have such system, and in the first part of our exercise, it is necessary to find the velocity of the body at the moment in time when it comes off the surface. Okay, maybe you have some ideas.
My first idea is we can separate the F horizontally and vertically parts.
Yes, we can. We can define projections of this force on horizontal and vertical directions. I think I'll draw some coordinate axis. Draw coordinate axis. Coordinate axis x and y. X and y. X and y, and origin is O. And in these coordinates we can write fx part. What will be here?
Fx. So it's a horizontal, am I right? Yeah.
Yes.
So f cos alpha.
Yes, f cosine alpha.
Mm-hmm.
Okay, that's great. It will be f cos alpha. And it means that if we use here, it will be eta t cosine alpha. Eta t cosine alpha. And vertical part,
F sinus alpha, sinus alpha.
yes, f sinus alpha. Это t sinus alpha. Sinus alpha. Okay, that's great. That's great. And what the next step can we do?
If we know the force and time, maybe we can calculate the acceleration.
Acceleration, maybe.
F equal ma, yeah. F equal ma, yeah. We can.
Yes, a second Newton's law of
Mhm.
motion we can use, and find acceleration from here. So while body is slippering, it moves only in horizontal direction along this horizontal plane. So we can write that ma is equal to fx. Fx because we have motion in horizontal direction. In horizontal direction, before taking off, there is no movement in vertical direction. There is only horizontal. Это t cosine alpha. Okay, and how to find velocity from this?
Let me check. Derivative integrate. Integration of acceleration.
Yes, we can use the definition of acceleration. According to this definition, acceleration is equal to derivative from velocity. Derivative from velocity, and from here and here we will get that this derivative is equal to eta t cosine alpha. Okay, and our next step is to solve this differential equation.
Let me say. Okay. In, so we need the integral integrated.
Yes.
Mhm. So f velocity must be equal integrate a dt. No, velocity dt. So the v equal integrate nt cos alpha dt.
Yes.
Mhm.
Yes. First step before integration is to separate variables. And it means that we have to transform this expression, and in left side will be variable v, and in the right side will be variable t. And differentials shouldn't be in denominator. So both condition may be met if we multiple left and right sides by dt. So we will get eta t cosine alpha dt. Cosine alpha dt. Cosine alpha dt. So here we can integrate this because variables are separated. So we can write integrals. In left and right sides of this expression. And to avoid integration constant, in result, we need to set integral limits. We need to set integral limits according to the initial condition.
So okay, t0 to t. T0 da also equal 0. 0 to t must be.
From 0 to t,
T, yeah.
yes. So I'll resign this with head, and to avoid the same symbols in integral limit and in integrand, and because this is not the same. And here from 0 to v, from 0 to v, okay. And after integration, we will get v is equal to eta t to the power of 2 cosine alpha divided by I have forgotten something. I have forgotten m.
Yeah.
So I'll add this. I
All of
have
them.
m, and here we also have m divided by 2, and yes, and here we have v is equal to eta t to the power of 2 cosine alpha divided by 2m. Okay, do you have any questions about this?
So far, so good.
Okay, but it represents dependence of velocity on time. Dependence of velocity on time, but we need to define definite velocity at a moment in time of taking off. when body separates from horizontal plane. So we still need to define this moment of taking off. So maybe you have
No,
some.
it's okay. It's okay. I understood.
Yes, yes. But maybe you have some ideas how
Ah,
to do.
okay. So after that, we can, if we know acceleration also exact time velocity, so we can find the distance x.
It will be it will be next part of our exercise. But
Hmm.
now we need to define
Mm-hmm.
moment in time when body takes off the surface. I think to do this, we need to take into account some more forces that
Hmm.
act in our system. What these forces are? What are these forces
Okay, give me a
that
second. Let me find in English. Uh, friction force maybe.
no
No.
plane is smooth, so there is no
Smooth, okay.
friction.
If there's no friction, there is only one force. We have just one force. So it's fx just. Am I right?
Uh, no, according to the condition, we have this force,
Mm-hmm,
uh,
yes.
but our body also has mass. If it has mass,
Yeah.
we can define another force from this condition.
Okay. Mg, you mean
Yes, it is force of gravity.
gravity? Yes, yes. Mg.
Mg, yes.
So mg minus fy.
This is force of oh, something bad with my zoom,
Mhm.
but I will cope with this as mg. mg, and also we have force of normal reaction. In general case, we have force of normal reaction. But in moment at a moment in time when body is taken off, this normal reaction will be equal to zero. It will be equal to zero, and fy minus mg will be equal to zero. Will be equal to zero at the moment in time when body is taken off. This is condition of taking off. This is condition, so we can use this to define moment in time that we need. So it will be some eta tv. Tv is definite moment in time where when our body is taken off. and this equal to 0. And from here we have that t taken off is equal to mg divided by eta sinus alpha. Sinus alpha. Okay, and velocity at this moment in time will be some t, some v with lower index v, or maybe we can use some another index, so we have according to this we have that this velocity is eta cosine alpha sine alpha divided by 2m here mg eta sinus alpha and to the power of 2 so it will be mg to the power of 2 cosine alpha and divided by 2 eta sinus to the power of 2 alpha. Sinus to the power of 2 alpha. Okay, this is the answer for the first part of the exercise. Yes, and the second part is to find the path that the body traverses until this moment in time. The next part is to find the path length.
Can you give me a second? What's the question?
Okay, maybe you can remember connection between velocity and path, or maybe definition of velocity, in other words.
So integration of velocity equal x.
Yes.
Yeah.
Yes. Integration of velocity will give us value that we need. We can use definition that v, absolute value of velocity, is equal to derivative from path length, and so from here we have that ds dt is equal to this. Is equal to this. So we can first step is to separate variables. In the left side will be ds, and in the right side will be this fraction multiplied by dt. This fraction multiplied by dt. So when variables are separated, we can integrate. We can integrate this, and now it is necessary to set integral limits.
I think it must be again same 0 to t.
Yes, from 0 to t, and in left side.
Or left side. Also 0 to t.
Not t, because we have s.
So 0 to s.
Yes, from 0 to s.
Oh.
From 0 to s. Okay, after integration we have s is equal to eta t to the power of 3 cosine alpha divided by 6m. Okay, so a path that we need will be some SV. And after substitution we will get m to the power of 2 g to the power of 3 cosine alpha divided by 6 eta to the power of 2 sinus to the power of 3 alpha. Okay, and do you have any more questions?
So far so good, it's fine for me.
Okay, that's great. That's great. That's great. If we understand everything, let's do some more complicated exercise. Number 11.
Yeah.
Number 11. Number 11 is more complicated. Number 11. I am not sure that we will do everything from this exercise, but at least a part of this, I think we will. A smart ball of mass m is connected by a thread of length L to sailing in the point O. The ball moves along a horizontal circle with constant angular velocity v. Find the modulus of the angular momentum vector increment related to the point O during a half of the turnover. So I will draw a picture. To explain what we have. In this situation. It is some vertical line, and the thread is here. Thread is here. It has, according to the condition, it has length L. Length L is defined, and this angle is some alpha. We don't know this angle, and it moves. It moves around. It moves around a circle. This circle is in horizontal plane. This circle is a trajectory of ball. Okay, and if we have rotation in this direction, what will be the direction of angular velocity omega?
It's a good question.
Direction of omega of this vector. Maybe you can remember. It is right-hand rule. If we have a right-hand rule, maybe if we have right-hand rule, right hand, these fingers shows the direction of rotation, and this finger will show the direction of angular velocity omega. So according to the right hand rule, we will get the direction. Omega. And point O is here. Okay, and in this case, what will be the direction of linear velocity? Of simple linear velocity? And because directions and geometry is very important in this exercise.
Velocity.
Yes, angular velocity is omega, and linear is v. And what is direction of linear velocity v? Because we need to show this on our picture. Okay, if we have rotation in this direction, in what direction? In what direction does this point moves? Does this point move?
Yeah, it's about xy if we
But we don't have any axis on the on picture.
so yeah, we know just angular things.
But we can
Mhm.
define direction of linear velocity.
So left part, uh,
It
left.
will it will move from us to the screen.
Mhm.
It will move from us. So we can write this in this way. We can show this in this way. There will be some direction from us to the screen. It may be shown in this way. This cross means that we have vector. We have vector that is perpendicular to the screen, to the screen, and directed from us. Okay, and I will also show. I will also show some values that we need. Some values that we need. We also need this. We also need this. This is some radius, and we need this. We need this height. This is distance between point O and the plane that contains circle. So our next step is to define is to define is to find is to find this and these values. Okay, maybe you have some ideas how can we find these values.
Nope.
Okay, and we may use another way. What is the first step? To solve any problem of dynamics? Any problem?
For any problem, define the variables, then separate the x's.
Define variables and separate x's. Okay, we may do this. So let's define some x's. Okay, let's define some x's. For example, we can define. Axis axis x, and axis y, and some origin. We have point O, but here I will use O1, for example. Okay, we have defined coordinate axis. So what to do? What to do next?
Try to find force or
Yes,
velocity. Mhm.
yes, to find forces. Okay, that's great idea. Uh, to find forces, and what forces do we have in this case?
Angular momentum force,
Angular momentum force.
or something like that.
Mm,
In Turkish, I know. Let me say it in English.
no, maybe you can define some force connected with mass m.
Okay, mg. It's always
Mg.
mg.
Mg, yes. Yes, it will be mg. It will be mg. And if something is difficult to say in English, you can also draw it on the screen. Mg. And what else do we have?
So angular. Okay, give me a second.
Because if we have only,
Centrifugal force.
I understand. I
It
understand what you
must be
mean.
something like that.
Yes, I understand. I understand what you mean. This will be force of inertia.
Hmm.
Force of inertia, but as you can see, if we have only this force and some horizontal force, the body will fall down.
Okay,
So
yeah. So yes, you're right. It's something like that for
yes.
up part.
What does prevent a ball from falling down?
Okay. Rope density, something like that.
Please.
Rope density about. Give me a second. Let me.
Rope tense.
Something.
Yes,
mm,
yes, yes, yes. Rope tension.
Rope tension. Yes, yes. Rope. No, rope density.
Yes, because according to the condition, it will be some thread,
Mm-hmm.
but yes, we can say rope. Okay, force of tension. Force of tension or tensile force. Tensile force F. O. That what we need. That's what we need to solve our problem. I think I will draw again. I will draw again these forces, but I will move mg. I will move mg parallel to itself in this way. In this way. So we will have force of tension F, force of tension F, and we will have force of gravity mg. Force of gravity mg. And sum of these two vectors will be here. It will be something like Fn. And this Fn will not be compensated. Fn will not be compensated, so it will cause acceleration. It will cause acceleration according to the second Newton's law of motion. And what acceleration? What acceleration will cause this force, Fn?
If it is R constant, it's not, we go different things.
R is
Fn,
constant, of course.
so Fn equal centrifugal force. It must be.
Yes, it will be something like
Oh,
this. Yes, and what type of acceleration will cause this force?
acceleration of Fn is 0.
I think 0.
Why not 0? If it is R is equals R is constant, F
But
acceleration must be 0. For if we talk about just Fn.
Tangential acceleration will be 0. Tangential acceleration will be 0, but when we have a motion around the circle,
Okay, yes. I got the
uniform
point.
motion around the circle, we always have normal acceleration.
Yeah.
Because vector of velocity, of linear velocity changes, changed its direction. Direction of velocity is changes. So we have normal acceleration. We have normal acceleration. Normal acceleration is always directed to the center of the circle. To the center of the circle. If trajectory is circle, it is always directed to the center of it. Angular, this normal acceleration. And this normal acceleration is caused by force Fn. Caused by force Fn. So we can write MAN is equal to Fn. Is equal to Fn. Okay, and how can we define this force Fn? Because here we still have two unknown variables. Two unknown variables, An and Fn. Two unknown variables and only one equation. So we cannot solve this. So we need something. We need something more. We need some more equations. Okay, and what do you think about this angle?
So Fy must be equal Fmg.
Fy must be equal mg.
Or something like that on the equation.
Okay, but what about angle in this
Angle alpha.
alpha? Yes,
Yeah.
it will also be alpha, of course. It will also be equal to alpha. Okay. Okay, it will be alpha. And if it is alpha, how to connect, for
F
example, mg and fn?
Okay, so if cosinus alpha equal Fn, so if sinus alpha must be equal mg,
Not quite. F cosine will be mg.
f cosine mg. Let me check.
Yes,
Yes,
because
90 degrees. Yeah, you are right.
okay. So f
Mhm.
f f cosine
Cosine.
alpha is equal to mg.
Mg.
Mg. Okay, and f sinus.
Fn.
Yes, sinus alpha is equal to fn. Fn. Okay, and here we have three equations, and one, two, three, 4, and four variables. And four variables, so we still cannot solve this. We still need some more equations.
Mm,
Where can we get them?
What's the fourth variable? Fn, An,
Uh, okay, it will be 1, 2,
yes, 2.
3, and
Yes, alpha, and last one, F. F can be gone. Uh, I think F can be gone.
uh, we can exclude this. We can exclude this, but we still need one more equation.
So let me think. Let me think. Still, we didn't use angular things, but
Maybe we still can get something from geometry and kinematics.
maybe why not?
Because here we have written something from dynamics, but we still didn't use any kinematics and geometry from this picture.
So tangent alpha, FNMG,
Okay, maybe
tan
what do you think about connection between R, alpha, and L?
L, L. Wait a second. Let me think. L sinüs alfa, R, let me, yeah,
L sinus
sinüs
alpha is
alpha,
equal to
A,
R.
yes.
Yes, R is equal to L sinus alpha. Sinus alpha. Uh, but we have obtained one more unknown variable. So we still need
One more
one more equation.
equation. Okay.
Maybe you can remember something about connection of this acceleration an, normal acceleration, and angular velocity from kinematics.
I don't remember. And angular velocity vt equal
Angular velocity is here, and normal acceleration is here. And what is the connection between them from kinematics?
mv equal momentum, so angular momentum. No, I don't. Uh, I forgot.
It will be an is equal to omega to the power of 2 multiplied by r. Multiplied by r. Do you remember this?
Yes, also.
Okay. And so we have five equations. 5 equations. 1, 2, 3, 4, 5. Okay, and 5 variables. So it is possible to solve this.
Okay.
If equations are independent, of course. If all equations are independent, it is possible to solve this. Okay, let's try to solve these equations. Maybe I will substitute this here, and I'll divide these two equations one by other. So we'll get m omega to the power of 2r is equal to Fn and here we have f sinus alpha divided by f cosine alpha, and it is equal to Fn divided by mg Fn divided by mg, and from the last equation, from the fourth equation, sinus alpha is equal to r divided by L. Is equal to r divided by L. Okay, do you have any questions about this?
So sinus alpha divided by cos alpha tangent alpha, so it makes sense. Yeah, it's okay for me.
Okay, that's good. So we will have m omega to the power of 2r is equal to Fn. F and F vanishes, so it will be tangent alpha is equal to Fn Fn divided by mg. Divided by mg. And the sinus alpha is equal to r divided by L. R divided by L. Okay, and let's find tangent from sinus. Tangent alpha is equal to sinus alpha divided by cosine, and it will be according to trigonometric formula plus or minus square root of 1 minus sinus to the power of 2 alpha. And what sign do we choose here? Plus or minus?
Is it just about direction? So mine plus, I think. Let me think. Minus one. Nine. I prefer plus. I choose plus.
Okay. Yes, it will be plus because according to the picture, we can see that alpha is between 0 and p divided by 2. And for these angles, tangent will be positive. Tangent will be positive, and if it is positive, we have to choose plus near the square root, because tangent is positive. And so we can use here r divided by L square root 1 minus r divided by L to the power of 2. And from here we can simplify this. We can simplify this expression. And we will have L to the power of 2 minus R to the power of 2. So this is tangent alpha. And from this equation, we have Fn is equal to mg tangent alpha, and it is mg r. Because of this, it will be mgr divided by square root of L to the power of 2 minus R to the power of 2. Minus R to the power of 2. Minus R to the power of 2. Okay, do you have any questions about this?
Let me check. It's fine.
Okay. Okay, and we can substitute this Fn in the first equation, into the first equation. So we will get m omega to the power of 2r, and this is equal to this, and from this last equation we can define r. We can find r from this equation. So what do we have? So m is gone, and we will have and r is gone. The first solution, we have first trivial solutions that r is equal to 0. But it doesn't make any sense for us. It doesn't make any sense because according to the condition, we have motion along a circle. So circle with a radius equal to 0 doesn't make sense. So we have r doesn't equal to 0. We have r is not equal to 0, so we can divide left and right sides by r. So we will get omega to the power of 2 is equal to g divided by square root of L to the power of 2 minus R to the power of 2 minus R to the power of 2. And from here we have L to the power of 2 minus R to the power of 2, and this is equal to G squared and omega to the power of 4. Omega to the power of 4. And from this we can find R. R is a solution of this equation. It will be plus or minus square root of L minus G to the power of 2 and omega to the power of 4. To the power of 4. Okay, do you have any questions?
No, equation is complicated, but it's okay.
Okay, and now it is necessary to choose plus or minus. How do you think? What sign should we choose?
Also plus.
Yes, because radius cannot be negative.
Negative.
Radius is always a positive number. It is always real positive number. Okay, so we have found that r is equal to this square root. Okay, maybe we can find from here. Maybe we can find h.
H. So it must be came from trigonometry.
Yes, it may be. it may be found from trigonometry, but it will be quite a long way. We may use some simpler way.
So okay, we need the equation R and H about, so let me check the force equations. L sinus alpha equal R. So L cosinus alpha. What?
Yes, we can do this, but
More
if we
better.
if we use H is equal to L
Cos alpha,
cos
cosinus.
alpha, we will have to define cos alpha from
R.
here,
Yeah, you're
and it will be square root. It will be square root, and under this square root we will have this.
yeah, you are right. You are right.
It may be done. It may be done, but it is a long way. It is possible to do it simpler. From the right triangle. From the right triangle, we have in the right triangle we have this, and we now have this.
Yes.
And if we have two sides of the right
Okay,
triangle,
Pythagore theorem. You're right. You
yes,
mean.
yes, it will be Pythagoras theorem. So h is equal to square root of L to the power of 2 minus R to the power of 2 minus R to the power of 2, and we will have here square root of L to the power of 2 minus L to the power of 2 minus G divided by omega to the power of 4. To the power of 4, and we will have G to the power of 2 divided by omega to the power of 4. Omega to the power of 4, not 2, it will be 4. It will be 4, and we can get this square root. It will be absolute value of G divided by omega to the power of 2. And the absolute value of positive, because this is positive, so we can write it as G divided by omega to the power of 2. Okay, do you have any more questions?
Nope.
Okay, so we have found this height h. This height h, and how to define absolute value of linear velocity. If we know radius, and if we know height, but we need radius, and we need omega. Can
Velocity.
you remember from kinematics the connection between velocity and angular velocity? So if we have V, omega, and R, what is the connection between these values? Okay, the connection is V is equal omega multiplied by R. Omega multiplied by R. It is from kinematics, and so it will be omega multiplied by this square root. Multiplied by this square root. Okay, do you have any questions about this?
No.
Okay, it was the first part of this exercise. As you can see, it is difficult. It is difficult. It is a lot of three-dimensional geometry. Three-dimensional geometry, vectors, vectors, forces, kinematics, and the next the next step is to find angular momentum, but I think we don't have enough time. We don't think enough time, and I think it will be enough for us for today. And I just only say that it is possible to get some additional to get some additional points. It is possible to have some additional points by doing homeworks. And next homework will be number 10 from mechanics. Number 10 from mechanics. If you want some additional points to improve your final grade at the end of the semester, you may do this exercise number 10.
Okay, teacher. Thank you.
Okay, thank you for your attention, and I hope to meet you next week,
Sure.
Wednesday.
So, goodbye. See you. Have a nice week.
Okay, have a nice week. See you later.